All right, so this is the second page worth of notes for the review for the Unit 10 for the final exam. On the other page, we went over just simplifying radicals and adding and subtracting them. Now we're going to go over multiplying radicals. And before we do that, I want to make a little chart here, because we need to remember that adding and subtracting is different than multiplying. So if we're adding and subtracting, remember they have to be, must be like radicals, right? Then you'll have to simplify first. First simplify, and then add the coefficients, right? Add coefficients. Radical stays the same. All right, so I'm going to have to move this over, right? So this was the key thing, right? Adding and subtracting, they must be like radicals. So in order to create radicals, we simplify first, then we add or subtract the coefficients, but the radical stays the same. Multiplication is very different. So multiplication, we don't even have to care about like radicals. We just simply multiply. No like radicals needed. For multiplication, no like radicals are needed. Instead, we just go straight to multiply the outside numbers, multiply the inside numbers. So the first step, we don't even care about simplifying first. So in adding and subtracting, we simplify first and then combine. But for multiplying, we simply multiply first. And then we simplify. So we reverse this, right? Adding and subtracting, they have to be alike, so we simplify and then combine. Multiplying, they don't need to be alike, so we multiply and then we simplify. So we're going to do one of these together, and then you're going to do one of them on your own. So let's do this first one together right now. So again, it's multiplication, so we don't care if they're alike, we just start multiplying. So we multiply the outside number by the outside number, so 2 times 3 would give me 6. Then we multiply the inside number by the inside number. So again, 2 times 3, but now it's square root of 6. Then we have to try to break this up. So we have to think about our list of perfect squares, right? I don't have to go any higher than that. 4 doesn't go into it evenly, neither does 1. If it did, we would need to simplify. Since it doesn't, that's our final answer. All right, so go ahead and pause the video and try number 2 on your own. All right, so first thing you should do is multiply the outside. So 2 times -4 would give me -8. Then you should have multiplied your inside numbers. 6 times 3 gives me square root of 18. But this time we're not done, because there is a perfect square that goes into 18, and it is 9. So we'd break this up into square root 9. 9 goes into 18 twice. Don't forget to bring your -8 down out front. Now we simplify any radical that we can simplify. Well, we can take the square root of 9. Square root of 9 is 3. Can't take the square root of 2, so it stays in the square root, and then your -8 gets brought down out front. Remember, if there's any numbers on the outside, we multiply them together. So -8 times 3 is -24. Square root of 2 should be your final answer. Okay? So now the next thing that we're going to look at really does just deal with multiplication again, but on a bigger scale. So now, instead of just simply multiplying like we did in 1 and 2, you're going to have to distribute. Okay? And you know you're going to have to distribute if there's an addition or subtraction sign in the parentheses. Okay? If there is, then you're just going to follow the distributing rules and multiply the outside by each term in the parentheses. Remembering that you multiply and then simplify. Now, when we did this before, I was very clear that I wanted to see each of the multiplication steps and the individual simplification. So we're going to do number 2 together. And you're going to change this other 2 that's in the front to a 1 because it's a mistype. So we're going to do number 2 together, and then you'll go back and do number 1 on your own. So first thing we're going to do is distribute the negative 6 to the, or the square root of 6 to the 5. So we're doing square root 6 times 5. So then you have to ask yourself, can you actually multiply these together? And the answer would be no, because 6 is inside the radical, 5 is not. Now before, some of you were writing a coefficient of 1, which allowed you to say, oh yeah, I can do 1 times 5, which is 5, and then there's nothing to multiply the square root of 6 by, so it just comes along. Now you should continue simplifying this if you can. So my perfect squares, right? 1, 4, 9, 16, 25. Well, the only number less than 6 would be 4 and 1. 4 doesn't go into it. We don't have to worry about 1, so this one is fine the way it is. Then we're going to go ahead and we're going to distribute the square root of 6 to not just square root of 4, but negative square root of 4, because there's a minus sign here. So this is square root 6 times negative square root 4. Right? And again, we could always put those invisible ones out front if you want it to, so that then you can remember to do 1 times negative 1 is negative 1, and then 6 times 4 is square root of 24. Now you can't leave it like this because you have to continue simplifying if you can. And there is a perfect square that goes into 24 evenly. It's not 25 or 16 or 9, but 4 does go into it evenly, and it goes into it 6 times, and don't forget to bring down your negative 1 out front. So really this is a combination of multiplication and addition, right? So we multiply, we simplify, square root of 4 is 2, negative 1 gets brought down, square root of 6 brought down. Then we can multiply our outside numbers, so negative 1 times 2 is negative 2, square root 6. And then we can bring down the rest of this. So this is really 5 square root 6 minus 2 square root of 6. Now, if these are like terms like they are here, right, these are like terms because they both have a square root of 6, then we need to combine them together. So 5 minus 2 is 3. We have 3 square roots of 6. If these were not like terms, then we would just circle it and be done. But since they were like terms, we had to continue working on it. So I want you to try that first problem right now on your own. So go ahead and pause the video and start working on that problem. All right, so you should have already started working on this, and you should have already finished it. Now let's check your work. Make sure that you don't just wait till the final answer to check it, right? You should be checking each step of the way to see that each step is correct. So first thing we're going to do is multiply 2 square root of 7 times 5 square root of 3. Again, since it's multiplication, we multiply the outside numbers together. 2 times 5 is 10. Then we multiply our inside numbers together. 7 times 3 is 21. Now we would need to try to break this up into perfect squares if there was a perfect square that went into 21. So we would try 16. 16 doesn't go into 21. We would try 9, but 9 does not go into 21. We would try 4, but 4 does not go into 21 either. So then this stays the way it is. Then I need to go ahead and I need to do the next one. So now I'm going to do 2 square root of 7 times not just 4 square root of 7, but negative 4. So 2 square root of 7 times negative 4 square root of 7. All right, so we again multiply our outside numbers, and we would get negative 8. Then we multiply our inside numbers. And yes, even though these are the same, it's multiplication, so we have to multiply them. 7 times 7 is 49. Now we need to simplify this if we can. Well, 49 is a perfect square. The square root of 49 is 7. Bring down our negative 8. Then we can multiply. Negative 8 times 7 is negative 56. And then we can bring down our 10 square root of 21. These are not like terms, so then that's our final answer. All right. Last piece for today, which is all about dividing with radicals. All about dividing with radicals. So when we're dividing with radicals, what I would tell you is, remember, I would add a first step in here and say, check if denominator a perfect square. Remember, denominator means the bottom of the fraction. if the bottom is a perfect square, then we should just take the square root of it in order to get rid of it. But remember, the big deal is there is no radical allowed in the denominator. No radical allowed in the denominator. If you have a radical in the denominator, sorry, I'm going to zoom out so you can write that. No radical allowed in the denominator. If there is a radical in the denominator, then your problem is wrong and you need to keep going with it. So, if there's one in a perfect square in the bottom, we can go ahead and take the square root of it and be done. So let's look at example 1 to kind of guide us. Right now, there's a square root in the denominator, which is not allowed. So I need to get rid of this square root of 6. My first thing would be check to see if I can actually square root 6. But 6 is not a perfect square, so I cannot. Right? Then I would look to simplify the fractions by dividing outside numbers and inside numbers. By dividing outside numbers and inside numbers. Well, in this case, there's only one number inside, only one number outside, so I can't do any of the division there. If you do that, if there is a radical left in the, sorry, that shouldn't say numerator. Let's get rid of that. In the denominator. If there is a radical left in the denominator, multiply by the radical on the top and bottom. So in this case, we tried to square root the 6, didn't work. We can't divide this because one is outside the radical and one is inside the radical. So now to get rid of the square root of 6, we're going to multiply the top and bottom by square root of 6. Well, I can't combine these together because one is inside and one is outside, so we just have 2 square root of 6 on the top. But these are both on the inside, so square root of 6 times square root of 6 is square root of 36. Now again, we're not allowed to have the square root in the denominator, so then I try to square root it. The square root of 36 is 6. So now I have 2 square root of 6 divided by 6. I no longer have a radical in the denominator, so that's good. But again, you have one last step, which is simplify again if needed. So I would look at those outside numbers. 2 over 6 can be simplified. So I would do 2 divided by 6 in my calculator, change it back into a fraction, which is 1/3, and then that square root of 6 stays on the top, which then, normally we don't write the coefficient of 1, so it's just square root of 6 over 3. Now some of you might be tempted to divide this and say that it's square root of 2, but remember, this is inside the radical, this is outside of the radical, so we cannot combine them. So that's just your final answer. All right, so let's look at number 2. Let's look at number 2 here. So, first thing, check and see if it's a perfect square in the denominator. Is 24 a perfect square? No, it is not. So if it's not a perfect square, then we try to simplify the fraction by dividing outside numbers and dividing inside numbers. Well, there's only a 5 on the outside, but there are 2 numbers inside this fraction, 3 and 24, right? There are 2 numbers inside that fraction, the 3 and 24. So we should try to reduce 3 over 24. So if we do 3 divided by 24 and make it into a fraction in our calculator, it gives us 1/8. So really this is 5 square root of 1/8. Now remember, this is really like saying the square root of the top over the square root of the bottom, and then we have to decide where would this 5 go. Well, if I made the 5 a fraction, wouldn't it be 5 over 1? Which tells me the 5 goes in the numerator. Are we okay? Hopefully. So now I would try and simplify these again if I can. So I can take the square root of 1. Square root of 1 is just 1. So 5 times 1 gives me 5 in my numerator. Then I would try to simplify the square root of 8. Well, 8's not a perfect square, but I can break it up, right? The square root of 8 breaks up into square root 4, square root 2. The square root of 4 is 2, square root of 2. So now my denominator is 2 square root of 2. So I've divided. I've tried to simplify anything that I could. Now the issue is I still have this radical in the denominator. You're not allowed to have that radical. But that's the only thing that's not allowed. So since that's the only thing that's not allowed, we clear it out by simply multiplying by just the thing we don't want, which is the square root of 2. So 5 times square root of 2 would be 5 square root of 2. These can get multiplied to give me square root of 4, right? So I have 2 square root of 4. Well, the square root of 4 is 2, and 2 times 2 would give me 4 in the denominator. Then I should check and see, can I simplify this any further? Can 5 over 4 be reduced? It cannot, and there's only one number in the radical, so then that's our final answer. All right, I want you to pause the video, and I want you to try number 3 completely on your own right now. So try number 3 completely on your own. When you finish, press play to see it worked out. All right, so I would have checked first to see if the denominator is a perfect square. It is not, so then we can try and reduce our fractions, right? 5 over 20. Can 5 over 20 reduce? Yes, it can. It would be 1 over 4. Then I would look to try to reduce 5 over 3. But 5 over 3 cannot reduce, so this stays square root of 5 in the top and square root of 3 in the bottom. But again, we see that pesky radical in the denominator, and you're never allowed to have a square root in the denominator. So now to get rid of it, we multiply the top and the bottom by square root of 3, right? So these two can get combined because they're both in the radical, which would give me square root of 15 with a 1. But remember, we don't have to write the 1 out front, so really my numerator is just square root of 15. In the denominator, we would multiply the square roots of 3 together to get square root of 9, and then we still have the 4 out front. Square root of 9 is 3, so 4 times 3 gives me 12 in the bottom. Now, I no longer have a radical in the bottom. My square root in the top cannot be simplified, and we can't divide these because one is inside and one is outside the radical. So our final answer is square root of 15 over 12. All right, so once you're finished with this, make sure you put this in your binder so that you have it to review for final exams, and then you can move on to the next activity.